Hi, my name is Margaret Abercrombie, and my project for this semester is called the Blind Saver Kitty Seat. Sorry about that. Okay, so what we're going to discuss in this presentation, we're going to hear an introduction and a reason for design. Then we're going to walk through the code together and look at the design process and schematics. And then at the end, we'll have a conclusion, and following the slideshow presentation, we'll do a demonstration. So my reason for designing this, and if you can look at the picture, I don't know if you can tell, but my kitten has torn through the blinds and she has gone through the blinds and is standing on the ledge of the window where you unlock the window. And several times when she has done this, she has fallen off and taken all of the blinds and the curtains with her. So I wanted something that could be automated to open when the sun came up, which is when she usually wants to look at the birds and look at the squirrels. And so that I wouldn't have to worry about getting up early in the morning and raising the blinds and giving her a place to sit. I could just have this automated to open whenever the sun comes up and then close whenever the sun goes down. And the blinds with the missing slats, it looks unsightly. So hopefully this design can alleviate some unsightly blinds on houses, which that is also a privacy concern. When you have all these slats missing in your blinds, people can look in and see what you're doing, and that's never good. And also, something I didn't think about at the beginning while designing this is this retracting and raising and lowering blinds is a good environmentally conscious thing. And especially in the winter, if you can open your blinds during the day and have the sunlight heat your home, that does save on heating costs. And I don't know about you guys, but I don't want to pay DTE or consumers energy any more money than I absolutely have to. So first we'll walk through the code. And how this works is there is a photoresistor that is constantly measuring the ambient light. And I have set a threshold to where if it is above a certain amount, then the blinds will open. And when it's below a certain amount, the blinds will close. And so, for example, if we were to make the threshold to where we could open the blinds would open. And then after the blinds open, there's a delay, and the cat seat opens and folds out. And this will stay open during the day while there's always light and it's meeting that threshold. And it's constantly checking, okay, if is the seat already down or the blind's already up, and it just keeps reading and reading until there's a change. And that change is when there's not enough light to meet that threshold. So when it's too dark to have the window open and have the cat sitting in the window, first the seat will fold back up to the window, and then the blinds will come down. But I have also made a kind of a safety consideration. If there's still a cat in the window seat when it's time to fold everything up, of course you don't want the cat to be folded up in the cat seat. That would be terrible. So there is a check. I use a weight sensor to check to see if a cat is still in the seat. And if the cat is still in the seat, it will not close until the cat is off of the seat. So I used two Arduinos for this design. And that is because I had two stepper motors and I was worried about running out of pins on the one Arduino, so I decided to use two. So the first Arduino is the Arduino that powers the blinds. And I used a simple 5-volt stepper motor, and you can see the wiring configuration. It uses digital pins 8, 9, 10, and 11 as inputs. And those inputs are either high or low, and that corresponds to how the stepper motor steps. Which this will make more sense. Because like, for example, if you have the input 1 as high and input 2, 3, and 4 as low, then it's only going to step one way, 1/4 rotation. And so in order to make a full rotation with the stepper motor, it does not go in order of the inputs. If you'll notice to the right, it goes 1, 3, 2, and then 4. which is something to consider when you are coding the stepper motors. If you get that order wrong, then it's not going to turn the way you want it to turn. The circuit diagram, and this is the circuit that measures the ambient light. And that ambient light is measured through a photoresistor, and that's a analog input, and that is read by the Arduino. And I have a LED light, and that's not necessarily for the design itself, but I kept that LED light there as kind of a debugging tool. So the light would be on if there was enough light to open the blinds, and the light would be off if there was not enough light. And it's the schematic for that first circuit. So I mentioned before that I used two stepper motors for this project. I won't go over the design and the configuration of the second stepper motor because it is exactly the same as the first. So this is the weight sensor that I mentioned earlier as kind of a safety measure to make sure that there is not a cat sitting in the seat. These are two load cells, and they measure weight through displacement on the metal part of the sensor. Lines A minus and A plus are input lines, and those will go to, this is a HX711 amplifier, and those signals will be amplified to the Arduino. And the other two pairs of lines are power lines. So I wanted these Arduinos to be able to communicate with each other instead of just relying on delays. So what I did was I connected the Arduinos through the transfer and receive lines, which are digital inputs 0 and 1 on both Arduinos. And you have to make sure that you ground the two Arduinos together. So what I did is I had after the first Arduino would open the blinds, it would send a number to the second Arduino to indicate, hey, I've already opened the blinds, it's time for you to open the seat. And then the opposite worked whenever it's time to close everything up. Whenever the first Arduino would read the light and decide it's time to close everything up, it would first communicate to the second Arduino to tell it to fold everything up. And then after the seat folded back up, then the first Arduino would lower the blinds. So this is the presentation as far as the slideshow goes. We looked at the reason for design of this project, what kind of inspired me to do this. We walked through a flowchart of the code. We looked at kind of the design process and a few schematics of the circuits. And now we will have a video demonstration of the project. Thank you so much. So here's the system all together. I have a wooden frame built. It is about 2.5 feet by 2.5 feet. The blinds and the seat are attached to a dowel rod. Both are attached to a dowel rod which turn. Both of these dowel rods are powered by these little 5-volt DC motors. And the way that I made the cat seat is it's kind of like a drawbridge, and there's paracord wrapped around this dowel rod, and depending on which way the dowel rod moves will indicate which way the seat folds.